lecture, Theory of Dark Matter, author Thierry Delors, date 6 August 2017. In this video, we are going to present as simply as possible a complete theory of dark matter. I ask you to be indulgent with my English and my French accent. If you look at this video, probably you know that presently one of the most important enigma in astrophysics concerns dark matter. In this video, I am going to expose as simply as possible the elements of a theory called Theory of Dark Matter that I have discovered. This new theory solves for the first time all the main enigma connected to dark matter. This theory has always been partially published, and at the end of this video I will give the references permitting to get the complete theory with all details, in particular all details of calculation. My lecture will be composed of 6 sections written on the plate 2. So I install plate 2. Sorry. In the first section, I will remind the main astronomical observations having led to the necessity to admit the existence of a dark matter in the universe. In the second section, I will expose the 4 main enigmas linked to dark matter. In the third part, I will present a theory called Mond theory that is the most cited presently in the astrophysical literature, and I will show why it is not interesting. In the fourth section, I will show how the theory of dark matter solves each of the 4 principal enigmas exposed in the second sections. In the fifth section, I will give a conclusion, and in the 6th section, the references permitting to get the complete theory with all the details of calculation. To begin with, let us recall the astronomical observations having led to the necessity to admit the existence of dark matter. The first kind of observations is exposed on the plate 3. So I install plate 3. In some galaxies, and in particular the galaxies in which we live, the Milky Way, if we predict the velocities of stars, considering only ordinary matter, we obtain the curves of the figure 1 of the plate 3. But the obtained experimental curve is the one of the figure 2 of the plate 3. So it appears that the observed velocities are much more important than the predicted velocities, taking into account only ordinary matter, and also that they are approximately constant, despite that they should strongly decrease if we took into account only ordinary matter. Decrease as a function of r, distance to the center of the galaxy. The gap between the predicted curves and the experimental curve leads to the necessity of admitting the existence of a dark matter, whose distribution in mass leads to obtain the figure 2. We will call the galaxies whose the orbital velocities of stars are approximately constant, as for instance the Milky Way, galaxies with a flat rotation curve. A second kind of observations is exposed on the plate 4. So I install plate 4. The galaxy clusters are concentrations of thousands of galaxies with a shape approximately spherical. We can get an estimation of their mass using a theorem called Virial's theorem, which is the equation 1 of the plate 4. This equation expresses that if Vm is the mean velocity of galaxy, then the squared of Vm is of the same order of Jm divided by r, with J universal constant of gravitational attraction, m the mass of the galaxy cluster, and r radius of the galaxy cluster. So this equation gives a relation between the mass of the galaxy cluster and the mean velocity of galaxies in the galaxy cluster. Here also the predicted mass is strongly superior to the mass of the ordinary matter constituting the galaxy cluster that we can estimate with astronomical observations. And this gap between the theoretical prediction and the observation leads also to admit the existence of or to assume the existence of a dark matter inside galaxy clusters constituting the missing mass. Other theoretical predictions based on general relativities lead also to predict a mass for galaxy clusters that is of the same order than the mass predicted using Virial's theorem. So we have seen the astronomical observations leading to admit the existence of a dark matter. We have 4 main enigmas connected to dark matter that are written on the plate 5. So I install plate 5. The first enigma is the nature of dark matter and the origin of its invisibility. The second enigma is the origin and the theoretical justification of the flat rotation curve of galaxies with a flat rotation curve. The third enigma is the theoretical justification of the baryonic Tully-Fisher's law. Indeed, several astrophysicists, in particular Stacy McGaugh, puts into evidence for galaxies with a flat rotation curve a law expressing a relation between the ordinary matter of those galaxies and the orbital velocities of stars in those galaxies, which is approximately constant. The experimental law is expressed in the equation 2 of the plate 5. If Mb is the mass of ordinary matter in a galaxy, Mb is also called baryonic matter of the galaxy, baryonic mass of the galaxy, then Mb is equal to a constant k multiplied by v power 4, v being the orbital velocity of stars in this galaxy. The fourth enigma is the interpretation of astronomical observations in galaxy clusters, and therefore to propose a model of dark matter inside galaxy clusters in agreement with astronomical observations connected to the dynamics of galaxy clusters. We are now going to consider a theory that is very popular among astrophysicists called Mond theory. This theory is presented on plate 6, so I install plate 6. Install plate 6. According to this theory, proposed by Milgrom, the Newtonian theory is no more valid if the gravitational field is too weak. This hypothesis is written on plate 6. But there are 4 points making it an uninteresting theory without future that are the following points written on plate 6. The first point is that the modification of the Newton's law assumed by Mond theory is completely artificial. It is just a calculation artifice in order to obtain the baryonic law of Tully-Fisher, constituting the third enigma connected to dark matter. We remind that this third enigma is a theoretical justification of the law. The baryonic mass mb of a galaxy with a flat rotation curve is equal to a constant k multiplied by the orbital velocity v of stars in this galaxy at the power 4. The second point is that Mond theory is in complete disagreement with Newton's theory and general relativity, despite that those theories are confirmed by many observations. The third point is that Mond theory needs approximations that are very bad quality. For instance, it makes the approximation that if m of r is the baryonic mass inside a sphere with a radius r, then m of r power a quarter is approximately constant, and this approximation is of very bad quality. It also makes the approximation that in a galaxy with a flat rotation curve, baryonic matter presents a spherical symmetry, which is not at all the case. The fourth point is that Mond theory is completely unable to interpret dynamics of galaxy clusters. We are now going to show how the theory of dark matter solves each of the four main enigmas that we exposed previously. The solution to the first enigma is written on plate 7, so I install plate 7. We remind that the first enigma, recorded on plate 7, was to determine the nature of dark matter and the origin of its invisibility. The solution to this first enigma, given by the theory of dark matter, is the following. The space, considered as absolute vacuum, is in reality constituted of a substance called dark substance, which is obviously translucent. It is this dark substance that constitutes dark matter, and is invisible because it is translucent. The solution of the second enigma is exposed on plate 8, so I install plate 8. I remind that this second enigma, written on the plate 8, was a theoretical interpretation of galaxies with a flat rotation curve. The theory of dark matter assumes the two following hypotheses written on plate 8. First hypothesis, the dark substance introduced in the solution of the first enigma owns a mass. Second hypothesis, it locally obeys to the famous equation of ideal gas, also called Boyle-Charles law, that is equation 3 of plate 8. P equals K0 rho T, with P local pressure, rho local density of dark matter, and T local temperature of dark matter. We then consider a spherical concentration of dark matter, of dark substance, with center O that is in gravitational equilibrium with a uniform temperature T, illustrated in the figure 4 of plate 8. The consequences of the previous hypothesis are written on plate 9, so I install plate 9. We obtain, using the two previous hypotheses and neglecting ordinary matter, the two following fundamental laws. Equation 4, and equation 5 of the plate 9. So the first equation, equation 4, is m of r equals k2r, with m of r mass of the sphere with center O and radius r, and k2 constant. K2 equals 2k0t divided by j universal gravitational constant, and T temperature of the spherical concentration of dark matter. And the second equation, equation 5, the squared of V of R equals 2k0t V of R, orbital velocity of a star at a distance r from O, center of the galaxy. So we see that V of R is constant. On the figure 5 of plate 9, we represented the 3 rotation curves. The curve predicted taking only into account the ordinary matter, curve decreasing strongly, the experimental curve, and the curve predicted by the theory of dark matter for a spherical concentration of dark substance in equilibrium. Both curves are approximately constant. The solution given by the theory of dark matter to the third enigma is exposed on plate 10. So I install plate 10. We remind that the third enigma was to give a theoretical justification to the baryonic law of Tully-Fisher, which is the equation 6 of plate 10. Meaning that for a galaxy with a flat rotation curve, mb equals kv power 4, with mb mass of ordinary matter in the galaxy, v orbital velocity of stars in this galaxy, and k constant. The solution to this enigma, given by the theory of dark matter, written on plate 10, is the following. We have seen that according to the theory of dark matter, the galaxies with a flat rotation curve were spherical concentrations of dark substance in gravitational equilibrium and with a homogeneous temperature. The theory of dark matter assumes the two following hypotheses. Hypothesis 1. Here. There is a very simple thermal transfer of convective kind between the spherical concentration of dark substance and the intergalactic dark substance in which it is immersed. Hypothesis 2. There is a very simple thermal transfer between any baryon, neutron or proton, and the dark substance in which it is immersed. This thermal transfer is expressed by the equation of plates 10, P equals P0, with P0 thermal power lost by the baryon and P0 constant. Expressing them at thermal equilibrium between the spherical concentration of dark substance in the intergalactic dark substance, we then obtain exactly the Tully-Fisher law. The solution of the fourth enigma, given by the theory of dark matter, is exposed on plate 11. So I install plate 11. It assumes the two following hypotheses written on plate 11. Hypothesis 3. The dark substance in the universe owns homogeneous temperature and density, except in spherical concentrations of dark substance constituting galaxies with a flat rotation curve. This is hypothesis 3. Hypothesis 4. Because of the expansion of the universe, P being a point of the universe not belonging to a concentration of dark matter, we must take rho of P equals 0 as density in P in the Newtonian equation of gravitation and in general relativity. Therefore, as in the case of galaxies with a flat rotation curve, the dark substance constitutes the main mass of galaxy clusters. With the two previous hypotheses, we can justify theoretically all the astronomical observations linked to the mass of galaxy clusters. The main points of the conclusions are written on plate 12, so I install plate 12. We have seen that the theory of dark matter, exposed in this lecture, solves all the main enigmas linked to dark matter. As it is written on plate 12, we remark moreover that this theory of dark matter is compatible with the Newton theory, the theory of special relativity, the theory of general relativity, the standard cosmological model, that is the cosmological model presently admitted by the scientific community. Nonetheless, the concept of dark substance that we define, meaning a substance constituting what is usually called emptiness, presents some analogies with the concept of ether that was admitted by the scientific community before the adoption of the relativity theory. Nonetheless, contrary to the pre-relativistic concept of ether, the concept of dark substance that we introduced is compatible with special relativity. In this video, we presented as simply as possible the theory of dark matter without giving details, and in particular, the complete mathematical justification of fundamental equations and results. Some publications on the web or in literature give all the details and calculations of the theory of dark matter. Those publications are exposed on plate 13. So I install plate 13. We see that previous versions of the theory of dark matter have been published in the review Physics Essay between 2000 and 2007. Those publications introduce some fundamental concepts of the theory of dark matter, but they contain some mistakes and need to be improved. So those previous versions do not correspond to the complete theory of dark matter exposed in this lecture. As indicated in 2 of plate 13, publications containing a complete version of the theory of dark matter in this lecture can be obtained either in the book written in French, Théorie d'or 9e édition, also Thierry Delors, Editions Books on Demand, Paris, or in the article in English, Theory of Dark Matter and Dark Energy, also Thierry Delors, on the sites of Open Archives Vixra of Internet Archives, with email address here. I'll let you a few moments in order to read the references on plate 13. Some important remarks concerning those publications are written on plate 14. So I install plate 14. As we wrote on plate 14, the editions of the book Théorie d'or, anterior to the 9th edition, do not contain the theory of dark matter complete exposed in this lecture, but only previous versions of this theory. Only the 9th edition contains the complete version of the theory of dark matter presented in this lecture. As is written on plate 14, the theory of dark matter constitutes only the first part of the article Theory of Dark Matter and Dark Energy that can be obtained on the websites of Open Archives Vixra and Internet Archive. The second part of the article is the theory of dark energy. And there are fundamental differences between the theory of dark matter and the theory of dark energy exposed in the article Theory of Dark Matter and Dark Energy. Indeed, we have seen that the theory of dark matter that we exposed in this lecture is compatible with the standard cosmological model. But on the contrary, the theory of dark energy, second part of the previous article, is not compatible with the standard cosmological model. The theory of dark energy should be the subject of another lecture on YouTube with the title Theory of Dark Energy, author Thierry Delorme. The previous important remarks concerning publications exposing the theory of dark matter are written on plate 14. This is the end of this lecture.